Okay, so let's look at number 28. And 28 said it's a question with Jules Verne sending a man to the moon by firing him outside of a cannon. So essentially, you got a big cannon and firing someone all the way to the moon. So let's draw a little dude. Alright, so if I write down my givens here, the first given is that delta x, or the length of the cannon, is equal to 220 meters. And then it says with the final speed, so v final, I'm going to write it just with the v, 10.97 kilometers a second. And let's just do the conversion for it real quick right here. A kilometer is 1,000. So what I would get is 1.097 times 10 to the fourth, and that's meters a second. All right. And then we're assuming that that when we're firing this, that an initial velocity is equal to 0. And what we're asked for is what is the acceleration. Okay, so there are my givens. So let's see, like, all right, if I look at here, in this equation, in these givens, there's nothing that talks about time. So I don't have time, so I'm going to think about my my formula or equation that doesn't have time in it. And the equation, the kinematic equation that doesn't have time, is the one of the ones that we derived in class. Okay, so now it's just about rearranging these and isolating what I'm looking for. So I'm looking for A. So let's just do this in a couple steps. So we have v squared minus v0 squared is equal to 2a delta x. And then to isolate a, I'm just going to divide both sides by 2 delta x. I'm going to rearrange the order. All over 2 delta x. Alright, so now I'm just going to substitute in my values. And my v, I have big number. And that big number is squared. v0 is 0 over 2, and my delta x is 220. Meters, I'm going to take the meters off, even though we know it's meters. I'll leave the units for the end. Okay, I'm going to pause it real quick and do the calculation. Okay, so the answer is huge. I get 2.7, let's see how many sig figs. We'll go 2.74 times 10 to the 10 to the fifth, and that's meters a second squared. Okay, so that is a gigantic number. If we look at what g is, like 1g, the acceleration due to gravity, that's equal to 9.8 meters a second squared. This is 2.74 times 10 to the fifth meters a second squared. So if we do this, we divide this, that leaves us a factor of 2.79 times 10 to the fourth. So that means that it's roughly 27,000 G's, which is crazy. So in this case, the dude would definitely not look like a man anymore. It would look like a pancake. Okay, I hope this helps. And we'll go over the other questions in class tomorrow.